Robin Hood and Little John running through the forest, hopping fences, dodging trees, trying to get away. Okay, we're back here in Unit 3, looking at C2 vertical motion, problem number 4. And in problem 4, we've got a bow and arrow, just like Robin Hood, and we're shooting it straight up into the air. 2 seconds later, the arrow's gone straight up to a height of 30 meters, and we're looking for the arrow's initial speed. So we're actually looking for VI here. A little weird. Let's draw a picture. Make Grandpappy Botzer proud. Bloop, 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 bloop. There's the arrow. And it's going... And it gets way up here to 30 meters. Now, while it's at a height of 30 meters, that may or may not be a maximum height. And in fact, they don't specify that it's a maximum height here, so we cannot say that that final velocity is 0. We can't say that. No. We just know it's at a height of 30 meters. We just know that this is the delta x. Now, what else do we know in this problem? Well, we know 2 seconds have passed, so we know time is 2 seconds. And we know that if we're shooting this arrow straight up, something's pulling it back down, and that's gravity. So we know our acceleration is that negative 9.8 meters per second squared. Negative because we're going to choose down to be the negative direction. So now we've got 3 things here. We've got a delta x, we've got a time, we've got an a. We're looking for VI. We can solve this out. If we consult our best friend, we actually see that equation numero 50 looks really nice here. So we can use this and go ahead and solve. Equation 5 is that a displacement delta x is equal to an initial velocity multiplied by time plus 1/2 the acceleration multiplied by time squared. So what we'd have in this problem is we would have 30, our delta x, equals VI multiplied by 2 plus 1/2 times negative 9.8 times the quantity of 2 squared. Now, normally I like to do the algebra before solving anything. I'm putting in numbers, but in this case, I think the numbers are actually a little easier to deal with here. 2 squared is 4, and 4 divided by 2 is 2, and 2 times negative 9.8 is negative 19.6. So we're going to get 30 equals VI times 2 minus 19.6. And now this isn't so bad to solve for us. We can just add the 19.6 to the other side to get 49.6 equals VI multiplied by 2. And then we simply need to divide each side by 2 in order to get rid of those and find VI. So in this problem, we quickly find that VI is equal to whatever 49.6 divided by 2 is. And that for us is going to be 24.8 meters per second. So that's how fast the arrow was shot out of that bow, from that bowstring initially. If we actually wanted to figure out how fast it is going at that max height, we could solve for VF. We've got a lot of information here, so we could solve for VF if we wanted to. What we'd actually see is that we lose 9.8 meters a second of that velocity every second. So 24.8 minus 9.8 would give us 15, and then in another second we'd lose another 9.8, which would give us 5.2. So after those 2 seconds, that arrow is still moving up top at 5.2 meters per second. We could solve that with something like equation 3, but in this case we were just looking for that initial velocity. So with that, this problem is finished. Pretty straightforward one. Feel pretty good doing that. So adios. Take it easy.